Hello and welcome to a short series of videos all about electric circuits. Now a lot of people find circuits difficult, and I think one of the reasons has got to be because most of the things we measure or look at in circuits are basically invisible. There's voltage, current, charge, etc. But there's nothing you can physically see most of the time. If I connect up a light bulb to a battery like this, then apart from the fact that the light bulb is lit up, you can't see anything happening in the circuit. It just lights up the light bulb. There's no very obvious reason why that's happening. So what we're going to cover to start with is look at the different things we can measure and get some labels so that we can actually start to measure those things and actually think about them. We'll then go on to looking at circuit diagrams and then deal with all the different things in a bit more detail. So let's get a list of all the things we can look at in a circuit. So I'm going to make a table that's got the thing and the label for the thing and the measurement unit for the thing and the symbol for that measurement unit. And this probably makes more sense if I put the first thing in, which isn't something that's very obvious to measure about a circuit, but it's something we're going to use at some point. So I'm going to call it time. So time is a thing that we can measure. And the label, when we use time in an equation, we usually give it a symbol T, a label T. And the measurement unit for time is seconds, and the symbol for that measurement unit is S, little s. So that's our first thing on the list. Now, if you think back to the static and charge part of the topic, when we have static electricity, we talked about the idea of electric charge. That's something else we can measure about an electric circuit. So we're going to put charge down. Now, when we use charge in an equation, we use the letter Q to stand for that. It's usually a capital Q to stand for quantity of charge. That's just a convention that we use. The measurement unit, if you remember for charge, is the coulomb, C-O-U-L-O-M-B, and it's named after Mr. Coulomb. The symbol for that unit is capital C. It's a capital C because it's named after a person. Okay, so we've got that thing. So the next thing we want to make a note of is electric current, because that's a very common measurement. So electric current, I'm not going to use the word electric because this is all electric. So current. And usually when we have a label to stand for current in an equation, we use the capital letter I. The reason for that is when early investigations of electric current were being done, it was being done in France, and they used the word intensity of current, or in French I think it was intensité du courant, to stand for current. So they used the capital letter I to stand for current. And the measurement unit is the ampere, or the amp for short, because it's named after Mr. Ampere. And because it's named after a person, we use the capital letter A to stand for amps. Okay, so the next most obvious thing to be able to measure in an electric circuit is voltage. Now, we try not to use the word voltage because it's a little bit vague. What we actually use is the phrase potential difference. Okay, so I'm going to put potential difference, but I'm going to put voltage underneath so we remember, or voltage difference. Now, when we stick it into an equation, we actually use the letter V to stand for voltage, but we sometimes put PD when we're talking about it for short. So if we're writing about it, we might say PD, P dot D dot, but we usually use the letter V to stand for it in an equation. This becomes quite confusing because we use the letter V here as well. So the measurement unit for the thing is the volt. The measurement unit for potential difference is the volt, and that's named after a Mr. Volta, so it's a capital letter V for the measurement unit. Right, the next thing you might be able to remember that we measure in circuits is resistance. So resistance, and just to be a little bit more conventional, when we label it in a circuit, when we label it in an equation, we give the letter R. And the measurement unit for resistance is the ohm, O-H-M, and it's named after Mr. Ohm. And weirdly, there was a letter omega in the Greek alphabet, which just starts with the same sound as ohm. So we use the letter omega. So it's an omega symbol. That's the way I draw it. Sometimes it has little upward ticks on the ends of the line. Okay, so That's resistance. That's another thing we'll measure. We're going to go into more detail about each of these later, and we'll bring in the equations for each of these as we deal with them. Next thing we want to look at is energy. Okay, and energy, whether it's electrical or anything, we usually use the letter capital E for energy. Okay, so capital E stands for energy, and the measurement unit for any type of energy, whether it's in an electric circuit or if it's in a machine, is the joule, Joule. And it's named after Mr. Joule, so it's a capital J for joule. And the final thing that I'm going to put down is for power. So power is given the label P, capital P, when we use it in an equation, and the measurement unit for power is the watt, W-A-T-T, which gives me my joke of what is the unit of power. And nobody ever laughs. Capital W is the symbol for the watt, and it's named after James Watt, so it's a capital W. So all of these are actually capital letters. You have to write them as capital letters. The only one that isn't is S for seconds, because seconds is not named after a person. So any of these, if you put them in as a unit after something, you have to have a capital letter. Okay, so those are the symbols and the terms that we're going to be covering in these series of videos.